Greetings of the day, dear students. In this video, we are going to discuss about the types of excitation, right? And we will see the different types of excitations we are having, and also it deals about the production of the magnetic flux in a device by circulating current in the field winding is called excitation, right? Now the magnetic flux in a DC machine, it is produced by the field coils which is carrying the current. Now depending upon the type of the excitation, we are having DC excitation and AC excitation. Again, with respect to the DC excitation, right, uh, how the current is provided to the field windings, the manner in which the field winding is connected with respect to the armature, we can have self excitation and separate excitation, right? Now in self excitation, again depending upon the manner in which the field winding is connected, we are having series excitation, shunt excitation and compound excitation. Again in compound excitation, we are having short shunt and long shunt. If it is self excitation, right, the current flowing through the field windings is supplied by the machine itself. If it is separate excitation, that is not the case, right? We can observe here, for example, in separate excitation what happens is the field coils are energized by separate DC source like this is the field winding, this is the representation of the field winding, and this is the representation of the generator. We will draw a circle, inside that we will draw we will represent with the letter G, and this shaded area indicates the brushes, right? So here this is the EMF generated EG, and V indicates the terminal voltage. IA is the current generated from the armature. Now in order to EMF to be induced in this generator, the field winding is to be supplied with some external means of DC supply. Because of, with the help of this DC supply, right, some current IF will be flowing in the field winding. The current IF is flowing through the field winding. Because of this current flow, flux will be established. Now because of the motion of the conductors in the presence of the magnetic field, EMF EG will be induced in the generator. This is how it works, right? Here in this case, IF is the field current and IA indicates the armature current and EG is the generated EMF. If we observe, if it is the type with series or shunt or compound, what happens is, observe here dear students, this is the armature and this is the series field winding RSC. RSC is the series field winding. In this context, this is the series field winding. If we observe the shunt winding, shunt wound, see here, the field winding is in parallel to the armature. The some amount of current, that is, if you apply KCL here, if you apply KCL at this node point, out of current IA generated from the armature, some part of current will flow through the field winding ISH and remaining part will flow to the load. I will flow to the load out of generated current IA, right? If you apply KCL here, the entering current, the total current generated at the armature will be equals to the IA will be equal to the I current flowing to the load, I plus ISH. Now if you observe, if you want the magnitude of the current flowing to the shunt field winding, ISH is simply given by the voltage across this winding is V, terminal voltage V divided by RSH, resistance of the winding. This is how we can calculate the shunt field winding current. Similarly, if you observe here, in series excitation, the current flowing through this field is same as the current flowing in the armature, and the current flowing in the armature is same as the current flowing in the series field winding is same as the current flowing to the low, because all these three are in series, right? Similarly, with respect to the compound, if it is short shunt, RSC is connected in this manner. Observe, RSC is like this. This is the current flowing through the series field winding. If you apply KCL here, IA equal to ISH plus I. Now, as this series field winding RSC is in series to the load, whatever the current flows to the load, the same amount of current will flow through this RSC, and some fraction of current will flow to the field winding depending upon its resistance, right, and the terminal voltage V. This is a short shunt case. This is the long shunt. In long shunt, you can observe RSC is connected in series to the armature, and RSH is also present. Separately excited, the field winding is separated like this. This is separately a given applied voltage from some external means of supply. In order to control the current flow to the field winding, we can connect an external resistance variable resistor. With the help of this resistor, we can control the flow of current flowing to the field winding, right? So this is how we can have the different types of excitation, and the key points are, we are having self excitation and separate excitation. Again, in self excitation we are having series shunt and compound, and the compound is further divided into short shunt and long shunt, right? So with respect to the excitation, it is nothing but the production of the magnetic flux in the device by circulating the current in the field winding. That is called excitation. That is called excitation, right? Thank you.